So I was explaining about non-blocking assignments. So in this, what happens is we make use of less than equal to operator for assignment. And in this one, as it happens in blocking assignments, right? That is in say here, y's assignment is blocked by x. So once x is assigned, then only the next statement goes around. So such thing doesn't happen. All can be independently assigned without having dependency on the previous. But we should remember some certain characteristics pertaining to non-blocking assignments. So here we can see that we have the blocking statements, blocking assignment statements. But here you can observe that these are non-blocking assignments since you have a less than equal to sign over here. Now what happens in this case? So here we observed all statements x is equal to 0 through reg b to reg a, equal to reg a are executed at time t time when it is 0 time unit. But after that, what happens is after 15 time units, reg A gets assigned, and after 25 time units, that is 15 plus 10, because in the statement it was in that form. So after 25 time units, reg B gets assigned, and count is executed after reg B. And since there is no delay specification, immediately after that, at the time 25 time units, count also gets initialized. So this is what is happening in this case. So let us see for the same, when we utilize non-blocking assignment, what happens. So here we can see that since these are blocking statements, so no need to worry about this. These executions start at time t is equal to 0, and x is assigned. After this, y is assigned. Then after this, z is assigned. It continues up to reg b is equal to reg a. So this is what happens for those three statements. Now coming down to the rest one, here we can see that reg a will be assigned its value at 15 time units. But what about reg b? That is register B. So that is this statement which follows register A, and both are non-blocking statements. So in this one, what happens is at time units when it is 10, at that time register B gets assigned. Whereas in the previous case, what was happening? It was getting assigned after, that is 15 was here, 15 plus 10. So at 25 time units, it was getting assigned. So then count is equal to count plus 1. Since again here you can see that it is non-blocking assignment, count plus 1 will be taken and assigned to count. Since there is no delay at time unit t is equal to 0, without any delay it will be getting assigned. Whereas in previous case, what was happening? It was getting assigned at 20 after 25 time units. So this is what was happening in case of blocking. So if they ask for differences between blocking assignment statement and non-blocking, so you can take an example having same say assignments, and in that you can modify few of the assignments as non-blocking, specify some delays, and then you can see how the difference will be. So this is how it goes around. Okay. So in non-blocking, it is not blocking, say execution of x equal to 0, that is x is assigned with 0. It is not affecting the count which is being assigned. So since this is a non-blocking, it is not dependent on all these things. So it is independent kind of thing. So this is what is happening in these cases. Okay, non-blocking assignments. Now, where do you observe the non-blocking assignments? In your circuits, you have observed that whenever you apply a clock to a flip-flop, for example, JK flip-flop. So two inputs are applied. So simultaneously, two inputs should be given to the flip-flop. Give me a second. There's a call. Okay. So this is that we can see that whenever we give input to a JK flip-flop, for example, J and K are simultaneously applied. So when we apply J and K simultaneously, whenever clock changes, say if it is positive edge triggered, negative edge triggered, so depending on how it is. So based on that, the J and K inputs are simultaneously applied to the flip-flop, and simultaneously we'll be getting the output Q and Q bar. So we can see such kind of operations wherein Q and Q bar are independent. It is like they are not blocking each other, whereas J and K are also independent. They are not blocking the simultaneous application or simultaneous say assignment of both. So we can see such kind of behaviors in hardware. So therefore, we should have some statements which help us in achieving these kind of behaviors. So here he has given an example, that is reg1 after one time delay, one unit of delay, time unit of delay, in1 is assigned to this one. Then reg3 also after one time unit of delay is assigned to the other one. And this is an event. So in1 say XORed with the into XORed with in3 is estimated immediately and assigned to reg2. Now here we should see that what happens and why the statement is put over here. The old value of reg1 is utilized. Now here when we are using non-blocking statements, remember one thing. It is like you are using some temporary registers to store the previous value and then use those previous values for assigning. So for example, I think they have given an example over here. So we can see that there is a race around condition which is specified, which explains what is this actually, what does the statement do. Okay. So here what is happening is, so here you can see that we have always block at positive edge, and this is a blocking assignment. A is assigned with value of B, and this is also always block. B is assigned with value of A. Now here what happens is, I don't know which one will be executed at the starting. Both start at time unit 0, at time unit 0. But which one will be assigned first, which one will be assigned next? So slight difference will be there. So that is not known. That is not known. So what happens is, and because there will be, it is non-deterministic, I can specify whether this is executed or this is executed. It is not, it is non-deterministic. I cannot determine which one will be executed first. And since it is a non-blocking assignment, right? Sorry, it is a blocking assignment, right? So what happens is, uh, it falls in a race around condition. It falls in a race around condition. So here there is one statement, here there is one statement. And what happens is when there is a race around condition, A is assigned with the value of B, B is assigned with the value of A. So what happens is this goes around and runs around, and in the end, you will be in both the variables, you will be having the same value. Say here, my main motto was to interchange the values of A and B. So that cannot be done here. So when you're using blocking assignments, right, that is not easy to achieve. If you want to achieve it, then you have to use, say, a temporary register and put some delay specifications, and then you interchange them. Now, what about when you use the same thing with non-blocking assignments? Non-blocking assignments. So there is one special feature of non-blocking assignment. What that special feature is, now here you have the value of B on the right hand side, and here you have the value of A on the right hand side. So what non-blocking assignment basically does is, internally it keeps this old value of B and old value of A in a kind of temporary register. It keeps B and A, these old values, in temporary registers. And once the execution starts, right, let this one start or let this one start, anyone. Again, it is non-deterministic, which always block will be executed. So no matter which one is executed, what happens is A will be assigned the previous value of the old value of B, which is stored in the temporary register. So this is done internally. This is done internally. Similarly, for this one, what happens is B will be stored with the value of the temporary value, which that is the old value of A. So which is held in the temporary register internally. So what happens is A will be assigned with the old value of B and B will be assigned with the old value of A. So by this way, what you're doing is A's content and B's contents are interchanged. A's contents and B's contents are interchanged. Whereas this is not the possibility. What it is doing is, whatever is the value of B, it is taking into A, and whatever is the value of A, it is taking into B at time unit 0. And since it is non-deterministic, what happens is it falls in race around condition, and in the end, you may end up with the A and B values having same values. A and B variables having the same values. So in order to avoid such kind of condition, we can go ahead with non-blocking assignments. So this is in simple, how do you exchange the two values? So in order to do that, I can go ahead with non-blocking assignments. So this is how we go ahead. Now, suppose if I want to use the blocking statements itself, I want to use the blocking statements itself. Then how do I assign this? So what I do is I store the previous values of A and B in a temporary register. I have to define that variable. I have to define those temporary variables. Here, I no need to define it. Here, no need to define it. But here, I have to define those temporary variables and then use those temporary variables for assignment. So this is what happens when you use non-blocking assignment statements. So you are avoiding the race conditions. So this is actually how it is going around. So if I have to read it right, this is how it goes around. Temporary A will be stored with the previous value of A and temporary B will be stored with the value of B. So your old values of A and B are stored over here. So once, and since this is blocking, right? Here we are showing it as blocking. So once this is executed, next this one will come and executed. Since it is falling within the same always block. It is falling within the same always block. Now remember that this always block is different and this always block is different. Therefore, these two statements will be executed at same time, even though if you're specifying it as blocking assignments. So here what is happening is, since these are blocking assignments, so this is actually how it appears. That is, it is explanation pertaining to this, how this is actually achieved when you go ahead with the blocking assignments. So here temporary A stores the value of A, temporary B stores the value of B. So this statement will be executed after this one is executed, but all will be starting at time t is equal to 0 with slight delta amount of time. What happens? A is assigned to temp A, B is assigned to temp B, and similarly you continue. Then you take the temp B value and store in A, and take the temp A value and store in B. So in this way, using the non-blocking, using the blocking assignment statements, you can exchange the variables, exchange the values which are present in the variables. So this is how it goes around. And this is how internally the non-blocking assignments will be working around. This is how it works around. These temporary variables are not declared in your non-blocking statements. You're not declaring them over here. You're not declaring them. So internally, how it goes around. So this is the possible way. So next comes the timing diagram, timing controls. So what does timing control specify? It is helpful in the simulation part. So we have timing controls, so which is basically required for your simulation. Try and you try to understand at what time what events are occurring or what delays you have to provide. So those all things you try to estimate. Now there are say three different methods of timing control. One is delay-based timing control, one is event-based timing control, and the last one is level-sensitive timing control. So first one, delay-based timing control. So here, what happens is the delay-based timing control, an expression specifies the time duration between when the statement is encountered and when it is executed. So when you encounter a statement and when the execution should happen. So that is being provided in this delay specification. So here already we had used these things. So for delay based specification, we use the hash this thing symbol, which is basically used for specifying the delays in the statements. Now here we can see that we can have delay specified as hash a number value, hash an identifier, and hash with the min, typical, or max expression. So previously we had studied regarding this. So in the rise time, fall time, and another one was turn off time. So these three, this thing we had specified minimum, typical, and maximum values for these things. So we can use the expressions pertaining to these. So we can specify the delay in for delay based timing control in three different forms: with a number, with an identifier, or with the expression which is relevant to min, typical, and maximum. So let us look at three examples pertaining to this one. So here we have we have the first one, regular delay. So using these again, we have three types of delay controls. That is, it is regular delay control, intra-assignment delay control, and zero delay control. So let us look at these things. So first one, we have regular delay control. So in regular delay control, what we have is we specify a non-zero delay, and we specify it on the left hand side of the procedural assignment. So this is your regular statements what you have used up to this time, this point. So here you can see what we have. So here we have specified some parameters, that is variables. So here remember, latency is a identifier, delta is a identifier, x, y, z, p, and q are all identifiers. They are all identifiers. And within this initial block, you can see that x is equal to 0 is the first statement which is present over here. So there, here you can see that you don't have any hash, any other value. So there is no delay specified for this one. Now, next one, these are all regular delay controls. These are regular delay controls. So next one, what we have, hash 10. So 10 is a number. So after hash, you are putting a number. So this number tells that when you encounter statement y is equal to 1, when you encounter the statement y is equal to 1, what you have to do is you have to assign the value of y equal to 1 after 10 time units. After 10 time units. So this is a delay control with the number. So the execution of the statement is delayed by 10 time units. Now, next one here, you can see that we have hash latency. So latency is what? Latency is a keyword. It is an identifier. Latency is an identifier whose value is 20. So instead of specifying hash 20, I can put hash latency. So because value is 20 over here. So what happens is when this statement is encountered, when the statement is encountered, its assignment will take after latency amount of time. So latency in this case, it is 20. Therefore, after 20 units of delay, Z will be assigned with the value of 0. So Z is encountered at some point. This statement Z is equal to 0 is encountered at some point. So from that time point, a delay of latency is introduced, and after that, the assignment happens. Assignment happens over here. Now here you can see that we have hash latency plus delta. So latency plus delta is an expression. Latency plus delta is an expression. So in our case, what is latency? Latency is 20 and delta is 2. Therefore, 20 plus 2 turns out to be 22. So here what happens is when the statement is encountered, p is equal to 1, the assignment happens after 22 time units. After 22 time units. Now similarly here hash y is an identifier. So after y, whatever value is y, whatever is the value of y, based on that, the assignment happens. Now here it is, which one? It is typical, min, typical, and max expression. So this is the minimum value, this is the maximum value, and this is the typical value. So these are all pertaining to what should be the rise time, fall time, and the turn off time. So these are all pertaining to those. You can have only one value, you can have more than one value. So remember, if you put hash and in bracket, if you put 4, it is identified that this is the delay which will be applied for rise time, fall time, and the turn off time. So this is from the previous discussion what we had. Okay. So this is a min, typical, max expression. So this is minimum value, this is a maximum value, and this is the typical value. And Q will be assigned based on these values. So this is your regular delay controls. These are your regular delay controls. Next, we have intra-assignment delay controls. So slight difference pertaining to these. So here, what was the case? Hash, whatever delay value was there was present on the right hand side of the assignment operator. Now it will be present on the, sorry, it was present on the left hand side of the operator. Now it will be present on the right hand side, intra, that is in between, intra. So here you can see an example. So they have defined the variables, and within the initial block, x is equal to 0, z is equal to 0. Therefore, there is no delay for delay control for these two statements. After that, you can see that y is equal to hash 5 x plus z. So intra, it is present in between the two, this thing. That is, it is present in between that assignment. So intra assignment. So in between of the assignment, it is present. So in this case, hash delay is present on the right hand side of the operator, assignment operator. Now, what is the difference between this and the previous one? So here what happens is, at time unit t is equal to 0, at time unit t is equal to 0, x plus z, this expression or whatever value is there, that will be evaluated first. That will be evaluated first. Then after that, what happens is, after 5 time units of delay, the value of that expression will be stored in y. So first at time at time t equal to 0 units, you evaluate the expression. You evaluate the expression, and then what you do is, after 5 time units of delay, you assign it to y. Now there is a chance that between 0 to 5 time units, what happens if x and z change? If x and z change, suppose I put some hash 1, x is equal to 1. So what is happening? Initially x was 0 and z is 0. But here what is happening? At time unit t is equal to 0, x plus y. So at time unit t is equal to 0, what are the values? It is 0 and 0. So 0 plus 0 will be taken and the value will be 0. Now after one time unit, if x is equal to 1, this will not affect the value of this expression. It will be 0 itself. It will not affect this expression. It will be retaining its expression value, and after 5 time units, right, it will be assigning it to y. So this is one slight difference what you can observe when you're using the intra assignment delay. So when you're doing this, first the expression is evaluated, and then after the delay amount what is specified, after that the value is stored in y. So this is what is happening in these cases. And in between, say 0 to 5 time units of delay or whatever delay is specified, if x and y changes, that will not be utilized. So expression once evaluated, it is done. No matter how many times x and z change in this case, it will not be utilized. So this is how it goes around. And the equivalent of this one is specified over here with your regular delay operation. So here what they have done, x and z they have assigned. And here as I specified, this statement will be encountered at time unit t is equal to 0. So when it is encountered at that time, x and z is evaluated. So it is like temporary variable is storing the value of x and z. And in between x and z, even if it changes, it will not be disturbing this temporary value. So what it does is hash 5 y is equal to temp x z. So the previous value of this expression will be evaluated and stored in y after 5 time units of delay. So this one, this statement is equivalent to this entire two statements together. It is clubbing two statements together. So this is how it goes around for intra-assignment delay. Now there is another one delay which is specified as zero delay control. Now this, it is not suggested to use in your coding for zero delay control. It is not suggested, but what does it mean, that we can just understand. Now, what happens in these cases is sometimes some of the statements have to be executed at the last once all the instructions are being executed. So that is the requirement. That is, you execute few of the statements have to be executed once all the statements have been executed. So after all the statements, say task is over, only the rest of the statements have to be executed. So in such cases, what we do is we go for zero delay assignment, and which is specified by hash zero. It is specified by hash zero. So what does this imply is, now here if we just see, we have two initial blocks. Both the initial blocks start at time unit t is equal to 0. At 0 time unit, both start at the same time. But what is happening? X is assigned with the value of 0, y is assigned with the value of 0. But here you can see that it is having a hash. If this was not there, then we would have a confusion what would be the value of x and y, because I don't know, it is not deterministic which one will be starting initially. It is not deterministic. So whether this initial block starts or this initial block starts. So depending on that, whether x will be 0 or x will be 1. So whichever is executed later, right, that value will be pertaining. So suppose this one is executed first and this one next, then in that case, x and y would be 1. But if it is turned around, if this one is first and this one is second, then x would be 0, y would be 0. So this is a bit confusing to identify what would happen in these cases. So now what you want to do is you want to execute these statements in the end once all the rest of the statements are executed. So what is done is this initial block and this initial block start at time unit t is equal to 0. X is assigned with 0, Y is assigned with 0. So all the instructions are being executed. Since only two are there, all instructions are being executed. Now, since there is a hash 0 over here, what happens is after this execution only, these executions take place. That is X equal to 1 and Y equal to 1. So in the end, what happens is X will be stored with the value of 1 and Y will be stored with the value of 1. This is confirmed. If hash 0 is not used, this is not confirmed. If hash 0 is used, right, then it is confirmed that x is equal to 1 and y is equal to 1 at the end of execution of this initial blocks. So this is what happens in zero delay control. Okay. So in coming forth session, we'll discuss regarding event-based timing control and the other one, that is level sensitive timing control. So these are the two things what we'll be discussing.